So we've looked at a few different series and sequences, but the one we're really going to focus on today is the harmonic series. And this, in fact, is one of the most important ones in this part of calculus. So a harmonic series is a special series, okay, because this is boundary series between what functions or what series converge to sum and what series diverge to infinity. Okay, so the harmonic series diverges to infinity. So if you take a look at the harmonic series, okay, this harmonic series here, notice that it goes down to 0. Okay, so we're eventually adding 0, but the problem with this series is that we don't go to 0 quick enough. So what ends up happening is you leave a bit of a gap here, and when we integrated something like this, in fact, we integrated this exact same one, if you integrate to infinity, you will get an area of infinity, okay, because this unbounded area has an infinite area. Now, compare this to a converging series, so geometric series, infinite geometric series, as long as the ratio is less than 1, these all converge. Okay, so these converge to sum, and these converge to sum because this one, although it goes to 0 as well, this one converges much quicker than that one. So the sums, these sums, or the areas, don't get to add up very quickly. Whereas this one here, although they're getting smaller and smaller, they're big enough to be added up. And as we go to infinity, the sum is infinite. Here, these go to 0 so quickly that it doesn't leave enough gap to be able to add up to an infinite sum. So it converges. So the harmonic series are very interesting because they have some sort of natural properties to them, and they're called harmonic series because they were first figured out from somebody recognizing that there's some musical harmonics or tones related to these numbers. Whereas if you have a length of 1, this tone that you would get from vibrating some column of air or some string or something like that, if you use exactly half that length, this is in harmonic balance. And then if you use exactly 1/3 of that length, that's in harmonic balance, 1/4, etc., etc. Okay, and those of you who do physics, you would have seen something like this in physics as well, because the nodes of these waves actually tend to match, so they will resonate with each other. Okay, so that's why they're called harmonic series. They come from that. Now, just for interest's sake, I think it's good for you to go watch this video because it tells you some kind of interesting innate property of this series, of this sequence. Okay, because there is this innate property in music, and there seems to be this innate property in calculus as well. And doesn't seem, I don't know if this is a coincidence that it is. In fact, I suspect that there's some universal fact about this series and the sequence that's very important.